G'day Miss Spack and welcome to Geological Hazards by Jack and Tom. Alright, today we're going to be looking at convection currents. And as you can see, there's a thin layer, which is the crust there over the top. You've got the large arrow and the smaller arrows all representing the flow and effect of magma. Now, can you imagine this is the Earth's surface up the top there, and down the bottom you've got what's called the lower mantle, which is much hotter, which is heated by the inner core and is much hotter. So what it does is it heats the magma, and when something is heated, it causes it to rise. And so we can see that magma rising up there. However, when it reaches the top and it's a lot cooler, it falls. So it sinks back downwards, as you can see down the outside there, and it forms what we call convection currents. And it's these convection currents that are what can displace and cause movement in the crust and the movement of tectonic plates as well. Now this process can take many, many years and it occurs extremely slowly. So the first kind of tectonic plate movement we're going to look at today is called convergent plate movement. And so this occurs when two tectonic plates are being pushed together by the convection currents as explained earlier in this video. So, as you can see here, we're going to use the example of a continental-continental plate collision. As you can see here, you have the continental crust, and then the lithosphere below, and the upper mantle as labelled in the diagram there as well. Now, another thing to mention about this is that continental crusts are extremely thick, and often they will not subduct, as has been shown in this diagram, and usually they will actually just push together and push upwards to form things such as mountain ranges. Now, an example of these mountain ranges, as you can see the arrows moving there in the video, as you can when they push together, they actually form mountain ranges. An example of this is the Himalayas. Around 50 million years ago, the Indian plate and the Eurasian plate converged. They pushed each other sideways and upwards, creating a mountain region known as the Himalayas. The tallest mountain in the world is located in the Himalayas, and there are also some other very tall mountains located there. A lot of its mountains are located above the perpetual snowline and will have snowfall permanently throughout the year. And when the Indian and Eurasian plate converged, they spread out horizontally, as was the case with the Himalayas. And it covers approximately 2,500 kilometres. So a hazard from this would be an earthquake, as they are often very common because of the pressure from the tectonic plates being pushed together. And obviously this can have severe social and economic impacts to an area, including obviously loss of life, as well as things such as loss of infrastructure and other things like that, which are often very hard to rebuild and very costly. And so, yeah, living near a mountain range or where convergent tectonic plate boundaries, such as a collision, continental-continental collision, is obviously going to be hazardous. Now, the next type of tectonic plate movement we're going to look at is divergent plate boundaries, also known as constructive boundaries. And when the plates diverge, the magma is able to rise up through the gap that is formed. And when it's underwater, when oceanic plate boundaries, as in the diagram, are being diverged, islands can be formed as the magma, cooled by the water, hardens and thus forms the islands. Other features formed by divergent plates include rift valleys. And when these two continental plates diverge, a rift valley can form where the plates have pulled away from each other. An example of a divergent plate boundary is the Mid-Atlantic Ridge. It separates the Eurasian and North American plate. It is part of one of the largest mountain ranges in the world. It lays in the ocean of the Atlantic, even though some parts are tall enough to reach sea level, and it expands roughly 2.5 centimetres each year, and is in total 16,000 kilometres long. It owes its formation to the North American and the Eurasian plates diverging, as well as the African and South American plates diverging. It's a combined effort there. This combined has caused the magma to seep through the Earth's crust, creating what is known as the Mid-Atlantic Ridge. And some of the hazards that can form from these divergent plate boundaries, often islands, which aren't really a hazard, but they can pop up very close to where people are and can impact waterways and things like that. However, one of the main impacts is that it can also form volcanoes as the magma pushes through. Things such as fissure volcanoes and shield volcanoes, which will be mentioned later in this video. And obviously these volcanoes will have lasting impacts on the area that it resides. Our third and final type of plate boundary is known as a transform plate boundary. And these are tectonic plate boundaries where the plates slide past one another in opposite directions or what is referred to as anti-parallel. Now the example in the diagram here is two continental crusts, and as you can see, they're sliding in opposite directions away from each other. And they can slide back and forth, however it causes a huge pressure to build between the rock, resulting in often in earthquakes when one slips unexpectedly as the pressure becomes too much for it to handle. And when this occurs, it is known as a fault. And these transform plate boundaries can stretch from anywhere to 100 to 100,000 plus kilometers in length. Now, one of the most well-known transforming plate boundaries is the San Andreas Fault Line, which has been featured in many movies. Located on the west coast of America, it splits the Pacific Plate and the North American Plate. The fault line cuts through the state of California, has been the cause of some devastating earthquakes, which have literally shook the cities of America. Its two biggest earthquakes occurred in 1857 in Fort Tejon, which measured a 7.9, resulting in 2 deaths. And the other earthquake was in San Francisco and was a 7.8, resulting in 3,000 confirmed deaths. And this fault line is 1,200 kilometers long and is currently expected to transform again in the near future. So one of these types of volcanoes is a composite volcano, and this is formed from high viscosity lava. So this is lava that isn't very runny and is prone to being very very sticky is a good way to describe it, and is formed from layers of ash and dried lava which has become rock. So these can form, because it's such a low viscosity, it can form such thing as a bubble over the top, and when this bubble blows, it can cause a volcanic eruption. It has a side vent, and these volcanic eruptions can cause things such as lahars, which is a muddy mudslide of debris and ash from the volcano. It can cause things such as pyroclastic flow, which is ash and other debris raining down the side of a mountain. And these hazards can cause disasters in the area which they are located. If there are towns nearby, if there are people nearby, the ash cloud can often cause devastating deaths, along with the lahars and pyroclastic flow, but it will cause devastating effects throughout the area. And so we can say there is a high correlation between the location of these composite volcanoes and disasters and the hazards. So here we have our shield volcano with low viscosity lava, which means it's extremely runny, and so it forms these long, gentle sloping sides of the volcano, and slowly over time it will form these, extremely long and gentle sloping sides of ash and dried lava. Some examples of these shield volcanoes are Mauna Loa, which is one of the taller ones at 4 kilometers high, Kilauea, which is 1,200 meters high, and Kohala, which is another one which is 1,670 meters high. And for the composite volcanoes, we have Mount Fuji and Mount Rainier, which is in Washington in the USA. And some of these volcanoes can be 2,000 to 3,000 meters in height above their bases, and even taller than that, up to 5+ kilometers high. So we're talking extremely tall volcanoes.